Hello, everyone. My name is Yiqun. I am from eBay Hadoop Team. Today, I want to share some optimization in eBay. On eBay, we have many large clusters with thousands of nodes, and we have faced many stability problem in our cluster. So we do the many optimization for this, and then our cluster become more stable than before. Okay, who am I? I am Yiqun. I have said I am a Apache Hadoop Committer and a PNC member, and I focused on the HDFS module. I made many contributions to the HDF, RBF, and Ozone. And I started contributing to Hadoop community from 2015, and I have more than 4 years for focus on the Hadoop. Okay, this is the agenda of my topic. There are 3 parts I want to talk about. The first is the Hadoop issues when faced, and this is the major content I want to talk about. The second one is the other improvement we did, include monitoring automation work in our cluster. And the third one is the future plan. I just will talk about something we want to improve and some existing issues we need to fix. Okay. This is the file issues we faced. Almost the issues is very common issues if you are working in Hadoop. If I think you will also meet these problems. Today I just want to share some solution from eBay and some new idea in community. The first problem is the missing block. This is related to the data availability. And the second one is the DataNode DU behavior, because the DataNode uses this command to calculate the latest data usage. And the third one is also related with the data. This is the unbalanced data across the DataNode, and the fourth is the unable close file. That is from the client side. Our users sometimes will told us their file cannot be closed. And the last one is the app log aggregation issue. Actually, the last one is not the HDFS issue. That is from the Yang, because Yang put the log aggregation into HDFS, but the number of the log aggregation will be very large, and sometimes will cause the problem. Okay. The first problem is the missing block. Missing block is important for us, because sometimes the user access the missing block, it will lead the job failed. So we need to take care of this problem. So in normal situation, there are two reasons will lead this. The first one is the incorrect replica set for file. Actually, sometimes this will be the system is when we will set a right replicate, but sometimes the user will override this setting. So sometimes when we found the missing block, we need to track the replicate value. And the second situation is that we have a row block placement lead this. This is the second situation is not easy to find. So we need to use some fsck command to look up its location. Then we need to track if it satisfies the record awareness. So in eBay we have met a case that the node host name change later the row placement. For example, I want to show an example. For example, we have a node. Its host name is like this. The first is the data center. Then we have a rack. Then we have a rack. We have a node ID. Then we will pass this host name to a topology location. That means this node is under this rack. Then, but sometimes the node being decommissioned, then come back again. The host name sometimes can be changed. Then he will have another rack name. Then he will have a different topology location. So this will lead a row placement like this. So the replica of the C block will place it in the C physical rack, because the logical rack that is the topology location is changed. So once the C rack is out of service, it will lead the missing block. So we need to take care of the host name change once we rely on the host name. Then we use the solution is very easy. We just to use the real rack way to improve this, and we pass the physical rack to the topology location. Okay, the second problem is the DataNode DO behavior impact. DataNode will use DO command to get the latest data used for each block pool directory. However, this is a very expensive command that sometimes can impact the I/O operation. And after HDFS federation mode, this command has a large impact for the system, because DO command will execute it in every namespace. So a general solution, we will to increase the DO interval time to reduce the frequency of the DO command. But this solution cannot solve the essential problem of the DO command. When the DO is running, it will still lead the high load, high I/O weight. So we are thinking, if we can find a way to lower its priority to run the DO command. So then we use the new DO command to we add the I/O nice with DO command to lower its priority to run. And this can minimize the impact of this command. Then we deploy the new DO command way to all the data node. Then we have see the node health trend to better, and we have an internal metric for this. The value of this metric is the average node ready. That means that if the DO run, it will block the system. Then we will think this node is unavailable at a short time. That will influence this result. So we can see our average ready percentage is become better compared with before. Okay, in community there are some alternative solutions talk about. The first one is the in-memory space usage calculation. This is a very good solution, I think. It don't need to use DF command anymore. It's just calculation the DFS usage in memory, because in DataNode we have the replica infer. We just reuse this replica infer and then do the sum operation for this, and we pass the used value to DataNode, then DataNode will report this value to the node. Another solution is that we can upgrade the DataNode storage layout. We can reduce the subdirectory structure to smaller. That means we will reduce the total number of subdirectories. We don't need to make so many subdirectories in the DataNode. It can reduce the directory inode cache used in system. Then it will speed up the directory lookup operation by inode metadata cache. But this way we will need to have an upgrade in DataNode, and there maybe we need to track if there is a compatible problem in HDFS, so we don't use this way. Okay, the next problem is the unbalanced data usage. Unbalanced data usage is also a very common problem because sometimes we have the unbalanced data writing or data locality writing. After the long time running, our system will be unbalanced in DataNode, especially if we have a very large cluster. This will be a very common problem. And this is a high data usage node will frequently behave high load appearance, and then it will impact our job running. So we improve our balance parameters to speed up the balance rate. And there are many related parameters related to this, like bandwidth and dispatch thread, move thread, and minimum block size, and threshold, and also we can adjust the heap size for balance. We increase many parameters to a large value compared with before, like thread number and the max size, minimum size. We are not recommended to move so many small blocks in HDFS because this is very, very inefficient. And we can dynamic to adjust the threshold of this. Also, we have enabled the available space policy in our cluster. Balance data after block being placement is not an efficient way. We can make the space choice in an early stage rather than the block being placed. So we enable this policy, and this policy is almost the same with the default placement policy. The only difference is that we choose the block location 2 times, and then choose the one with more available space, and there is a little cost for this, and I don't see the obvious impact for our system. So we enable this, and this is a large cluster that we can see the max usage is very close to median usage now. But if we speed up so quickly, it will also have some other problem, because the aggressive balance rate can increase the active load, and then it will lead some problem because node will be in a very busy state. So in community, we have talked about the way to enable the standby node to let it get blocks by the balancer. But this solution has not been merged in the community. But I think it's a very a safe way, because the get blocks call is very is not published for the client. It only used in DataNode service. So it's safe to do this change. Then we apply this change into our cluster, and we speed up the balance rate. We can see after enable this, even though the calculation is very high for this, but it doesn't impact the active DataNode service. Okay, the next one problem is the unable close file. This file often happens in the client. Sometimes our users will told us they have received some exception like this. He cannot unable to close his file after many retries. So then we see the log in DataNode, then we often found this log is not a complete log. And that often means that the DataNode is in a very busy state, but we don't know why the DataNode is very busy. Then we look at the source code, and we found this is caused by the incremental block report processing in DataNode. And then we found two related JIRAs. The first one is the IBR processing in DataNode, and the second one is IBR processing in DataNode. These two solutions is very similar. It uses a sync batch way to processing the IBR instead of a sync way. A sync way means that if DataNode finish a block change, it will report its increment block to the DataNode immediately. But this way will lead lots of the IBR request, and it will flood the DataNode. So we adjust the parameters of this two setting. Then we found our calculus becomes much better than before, and our calculus become more stable and few spike than before. Okay, the last issue is that the app aggregation log. Young app log is very small size with a large number and can easily use up DataNode memory once it's not deleted correctly in HDFS. We have met two app log issues in the past time. The first one is that we found the app log is with the incorrect replica set. Once when in a HDFS federation mode, it uses a raw file system by importing a VFS schema path and the raw file system with only one replica set. So we always see the one replica app log, then the missing blocks often appears. The second one is the deletion bug in job history. In job history, if the exception happened, it doesn't delete the app log anymore. Then this log will stored in HDFS, and it will use up the DataNode memory. Okay, there are some other improvements we did for our cluster. We enable the DNS caching server to avoid the DataNode crash due to write edit log timeout. We have met a case that our network broken. Then DataNode cannot find the DataNode address. then it reaches the time after of writing a log, then it crash. So we enable this in our master node to avoid this. And also we did some fine-grained monitoring and alerting rule to know the status of our master service. We also have missing block trend monitoring for all clusters to avoid the data loss. And we also have automation work for cluster maintenance. We have many clusters, and we have some automation detection for this, like bad disk tracker and the node decommission and the re-editor. Oh, this is the one monitoring for this. Okay. In the future plan, and we have some, this is just a recent plan for our cluster, like the RPC core of snapshot deletion. Deletion snapshot is very similar to delete a large directory in HDFS. In my opinion, deletion large directory is still a hard problem and have not a good solution to solve. And the second one is the slow startup for DataNode. If DataNode has a large metadata space, it will cost a few hours to start up. But in community, there is a very good solution now. It adds the subsection index right into the FS image. Then it can support the parallel loading, and it greatly speed up the DataNode loading. And we are considering to backport this change to our version. Also, we need some more automation work for cluster maintenance. And finally is that we have the upgrade plan to upgrade our version, our Hadoop version to the latest version, and the benefit for some good future. Okay, this is all that today I want to share about. Just some experience in eBay, yeah.